let's go ahead and run through our truth tables. So a truth table is something that determines, it tests the truth value of a given sentence or proposition here, right? Propositional logic is what we're dealing with in this case. So if A is true, then what should we expect from not A? So if it's true that Anne goes swimming, then not A would have to be, it would have to be false if A is true, right? Because this would say, well, it's not the case that Anne goes swimming. So that we just said that Anne goes swimming is true. So if it's not the case that Anne goes swimming, that has to be a false statement because Anne goes swimming was true. But if Anne goes swimming is false, then it is not the case that Anne goes swimming. That must be true because it's the opposite, right? So that's kind of how these truth tables work. You start by filling in the left-hand side with all possible combinations that could happen. And then you say, okay, so what does this overall sentence have to be on the right-hand side here? So that one's really easy and straightforward. It's just simply a negation. So that's kind of an easy one to test. Let's go ahead and look at the next hardest one after that. So again, since these are operators, they're connecting two separate sentences here. So that means we're going to have to fill out a lot more options here. If I just have two things, I have a lot of different combinations that I could do. They could both be true. They could also both be false. I'll put that down here. And then one of them might be true while the other is false. And it can go either which way there. So we have to account for both of those. So let's see what this would say. So if Anne goes swimming, Bob goes swimming. If both of those things are true, what does that make the sentence? Anne goes swimming and Bob goes swimming. Well, it must be true because both of those things were true. If we have Anne goes swimming is true, Bob goes swimming is false, then to say Anne goes swimming and Bob goes swimming, well, that's not true that Bob goes swimming. So since these two are connected, this whole sentence would be false because the entire thing was not necessarily true. In this particular case, you have Anne goes swimming and then Bob goes swimming, but Anne goes swimming is false. So it might be true that Bob goes swimming this time, but this said Anne goes swimming and Bob goes swimming. So the whole thing is joined together, but since Anne goes swimming is false, the whole thing has to be false because it breaks down. It's not 100% true. Here, it is false that Anne goes swimming and it's false that Bob goes swimming. So if Anne goes swimming and Bob goes swimming, this whole sentence is completely false altogether. So this is what our truth table looks like for the and operator. Right? It's only true if both things happen to be true. All right, the next operator is or. We have, again, two things joined together here. So that means we're going to have to set up all possible combinations. Either both are true, one's true, one's false. The same idea, false and true. And then the fact that they both might be false. All right, so Anne goes swimming and Bob goes swimming. They're both true. So this, since it's inclusive, right, we're defining this to be inclusive. So that means basically at least one of them had to be true. So this is true. Since at least one of them have to be true, then in this case, this is going to be true as well because it says Anne goes swimming or Bob goes swimming. So if Bob didn't go swimming, then Anne must have gone swimming. And that's the case that we have here, that Anne goes swimming is true. So that's true, the whole sentence. Same situation, just Anne goes swimming is false and Bob goes swimming is true. So this here, again, this whole sentence of A or B is true. And then lastly, where both of them are false, this will be false. All right, that's our truth table for or. All right, so now we're going to look at if then. So this here connects, if A is true, then B must be true. So I'm going to go ahead and fill out for a truth table. Possibility that they're both true, possibility that they're both false, and then alternating that one is true and the other is false. Okay, so let's think about what this says. If A is true, then B is true. Well, this sentence says if A is true, then B is true. So if they're both true, then that whole sentence, that must be true because it's saying that if A is true, then B is true. And in the case where they are both true, that works. In the case where B is false, this sentence says if A is true, then B is true. So here, A is false, or true, but B is the one that's false. So that whole sentence is actually wrong because in this case where A is true and B is false, this sentence said if A is true, B is true, but it didn't happen. So this is false. In this particular case, A is the one that's false and B is true. Now a lot of people will say, oh, well, this says if A is true, then B is false. So that whole thing must break down, right? But it actually doesn't. Because this sentence says if A is true, but it's not. So anything else that this sentence might conclude doesn't matter. So this whole sentence over here is actually true if A is false. And again, notice if A is false here, it doesn't matter that B is false again, because our premise that this was based on, if this said if A is true, it starts the whole sentence saying if A is true, but it's not. So it doesn't meet the qualifications. So this whole sentence can still remain true. So this is what our truth tables look like for the if-then operator. All right, now we'll look at the most complicated one so far, if and only if. So I'm going to go ahead and fill these out again. The case that they're both true, the case that they're both false, and then one true, the other false. All combinations listed out here on the left-hand side. All right, so this says A is true if and only if B is true. Well, they're both true, so this satisfies either condition. Now this says A is true if and only if B is true. But A is true and B is false. So since they're contingent upon each other, right, A needs to be true whenever B is true and B needs to be true whenever A is true. Here, that's broken because A is true and B is false. So it breaks down there. This is false. In this case, A is false and B is true. But again, they're contingent on each other. So here you have if A is true, then B is true. But here, A is false. So if A is false, then B is false. But it's if and only if. So that also means if B is false, then A is false. But that's not true because B is true. So this must be false again. Lastly, if A is false, then B is false. This is saying if A is true, then B is true. And if B is true, then A is true. But since both of them are false, just like with the if-then statement, if I had a false implying a true or a false implying a false, either way, this sentence is true on the whole because the premise is false. But remember, A and B, if and only if, that implies both directions. But in the case when they're both false, it doesn't matter. False implies false or false implies false. The whole thing ends up actually being true. So we have a true, false, false, true in these circumstances for the if and only if operator. So again, it's a little bit more of a tricky one because people think, well, false and false, the whole thing must be false. But it's if and only if. You can think of it like an equal sign. Whatever A is, B has to be. So if it matches, it's true. If it matches, it's true. Here, they don't match, so they're both false.